Let's look at this example question asking you to find out the trigonometric ratios. So the question says if a point 2, -1 is on the terminal arm of the angle theta, determine all 6 trig. So you can see I plotted the point P. Let's put a P here. So it's on the fourth quadrant. Right, and then if you decide this point, then you can draw the terminal arm here, and then you can see the angle means starting from the initial position and then turn all the way to here. Now of course we can have many more co-terminal angles who also ends at this terminal arm, but then they should have the same ratio. So let's just take this angle, turned counterclockwise as example. Okay, to find out the ratios, we actually look at this reference angle, the theta r, which is the reference angle of theta. So if you look at the reference angle, and then if you connect line starting from P perpendicular to the x-axis, so you actually form a right triangle. So this is the right triangle OPQ is actually a right triangle. You can see this is 90 degree here. So in this right triangle, so we already know how to find out the trig ratios: sine, cos, tangent, cotangent, secant, cosecant, right? And then they all should be positive. For example, I just give one example. If you look sine theta r, which is the reference angle, it should equal the opposite side PQ over the hypotenuse, which is OP. So PQ over OP, that's 1 over the square root 5, and we did find out the OP here using Pythagorean theorem to find out it's square root 5, and see it's positive. But now to find out the ratio for the original angle theta, not as reference, so we still look at this triangle. But the difference is we have to take the PQ or OQ as positive or negative depending on the situation. So for example, the PQ, this is actually the y coordinate of this point P, is negative, so I actually have to put a negative here. Okay, and OQ, it's because that's x coordinate is on the positive x-axis, so it's positive too. Okay, then if you want to find out the sine theta, it's a little bit different. So we still use PQ, which is opposite side over the hypotenuse, and then we got a -1 over square root 5, and we end up getting negative. So then if you compare the sine ratio and between the reference angle and the angle theta itself, if you compare them, you can see their absolute values are the same, right? So the only difference is the sine theta is negative. So you can see you never need to worry about the magnitude. You only need to worry about the negative sign. Okay, and then we're gonna do the same thing for the rest of the ratio, because this cosecant ratio is just the reciprocal of sine, so easily just take this, make it upside down, you get a negative square root 5, and the cos theta equals adjacent side OQ or hypotenuse OP, so you should get 2 over square root 5. And then the second ratio, again, it's a reciprocal of cos theta, so just take this one, make it upside down, and the tangent equals opposite side to adjacent side, so that's -1 over 2, so -1 over 2. And the cotangent theta, just again, it's adjacent side of opposite side, it's a reciprocal of the tangent, so it equals -2. Okay, so the question is done. And another thing I have to mention is when you find out this ratio, so you really look at the triangle formed by the reference angle, but the two legs, they may be positive, may be negative, but the hypotenuse is always positive. Right here, I put it here. Okay, so that's this question, and you can do a lot of similar question by using the same strategy. Okay.